Okay, the last one, I swear, is roots of complex numbers. All right, come on and focus. So this is a proof where I'm just going to go through. So if you had a complex number, u equals a plus bi, and it's an nth root of a complex number, z, if z equals u to the n, right? If u is a root, if I raise it to some nth power, I would get z back. So that really means you're just taking a plus bi and raising it to the nth power. So if we let u be s cosine of beta plus I sine of beta, and we're letting it be an nth root of your z, which is r cis of theta, then we know u to the n equals z. By substitution, I'm just substituting in what I defined u to be, and this is the definition of z. Okay, using de Moivre's theorem, I can rewrite with basically distributing in, if you want to think of it that way, s to the n, and then you have your cis n beta. Nothing happened on the right. So for these two to be equal, if this thing would focus, s sub n would have to equal r, and your n beta would have to equal your theta. But think about it, that theta, it's not just one theta, it's any theta plus 2 pi k, because we're talking about cosine and sine, and the period's 2 pi. For any k, 0 all the way up to n minus 1. Or in other words, your s, right, if I took the nth root of both sides, is equal to the nth root of r. And if I solve this for beta, beta is equal to theta plus 2 pi k all over n. So would you ever think to do that on your own? Probably not, but this helps us figure out the nth root of z. This is the definition you need. And so the nth root of your z, which is r cis of theta, is, this is what we will use in our next example. The nth root of r, notice you now have theta plus 2 pi k divided by n, where k is from 0 all the way up to n minus 1. So let's apply this to an example. Wrong page. All right, so number 6. I have 6 and 7, and then that's it. So find the fourth roots of 16. Okay, so it helps you if you would rewrite these in your trig form. So 16 is really 16 cosine of 0 plus I sine of 0. Because your cosine of 0 is going to give you 1, and your sine of 0 is 0, so it's just 16 times 1, which is 16. Okay, so here we go. So we have to find the fourth roots of 16. I like to keep track of my k's. Remember, we said k starts at 0. So for when k equals 0, this is a tedious process. All right, I'm following my equation that I had. I should probably maybe set it up like this. That would be not really any better, huh? So I'm following this right here. So I'm doing the nth root of r. So we're trying to find the fourth roots. So in this case, my n is 4. My r is 16 because of this right here. Come on, blurriness. Okay. And then my theta is 0. And then my k will change depending on which one I'm doing. And for all of them, it's going to be 4. So let me show you how this would go. So I'm looking at just to substitute in, I have the fourth root of 16 times the cosine of, I'm just writing this all out, your 0, which is your theta, plus 2 pi times your k, which is 0. Again, I'm just doing this so you can see how I'm applying this, divided by your n, which is 4, plus I sine of 0, which is, again, your theta, plus 2 pi times 0, which is your k, divided by 4. Okay? Well, for all of these, the fourth root, or in any case, the fourth root of 16, come on, is 2. So I'm going to have a 2. This all right here is just 0, as is this. So cosine of 0 is 1, and this is just 0. So my answer to this is 2. That's one of them. Now I have to do it for k equals 1. So again, I have the fourth root of 16, but I already know that's 2. Just showing you how this works. So now I would have the cosine of, my theta is still 0, plus 2 pi times k, this case is 1, it's still divided by 4, plus I sine of theta, which is 0, plus 2 pi times 1, all divided by 4. So, oh no, 5% battery. Okay, so that's going to be, I hope I don't die here. I hope it doesn't go. So, what am I going to get here? So this is really the cosine of 2 pi over 4, which is pi over 2, which is going to be 0. And here I get 1i. So my answer here is 2i. For k equals 2, I'm going to have 2 cosine of 0 plus 2 pi times 2 divided by 4 plus I sine of 0 plus 2 pi times 2 divided by 4. Running out of battery, guys. So I'm going to get here, this is going to be a negative 1 plus a 0. I'm going to get negative 2. That's my third answer. So I have 1, 2, 3. And my last one, oh my gosh, can I make it? K equals 3. I stop here because remember k was defined from 0 all the way up to n minus 1. N is 4, so I have to stop at 3. Plus that would make sense because that's my fourth root. So I have cosine of 0 plus 2 pi times 3 divided by 4 plus I sine of, again, I don't expect you to write all this out. This is just for learning purposes. So we're going to have 2 times 0 minus I, because you're going to get a negative 1, so it's going to be negative 2i. And I will have to finish the other video in a minute.